Hello and welcome everyone. Thank you for taking the time to join us today for our live webinar, where we will talk about mastering ServiceNow Predictive Intelligence and its best practices and insights. So this is Rajiv Goyal, a ServiceNow practice head at Royal Cyber. I will be presenting today's webinar. Before we move ahead, I would say feel free to drop questions on the topic or share your struggles and experiences. We will answer your questions. By the end of the session, the moderator will collect the most upvoted questions so we can answer them for you at the end of the presentation. Now let's touch upon the agenda of today's webinar. We'll talk about Royal Cyber introduction. Here we provide insight of Royal Cyber company. Then we talk about business challenges, what customers are currently facing. Then we'll give you an overview of predictive intelligence. Then we'll talk about the capabilities available in predictive intelligence. Then we have a demo followed by question and answers. Let's start off with a brief introduction about who we are. Royal Cyber is an IT consulting and digital transformation company specialized in services, solution, and software. We have been innovating since 2002 and have over 2,000 employees with 600 plus happy customers worldwide. Our headquarters is in Naperville, Illinois. We have offices located in different parts of the world, namely Canada, Mexico, Australia, UK, Saudi, South Africa, with delivery centers located in India and Pakistan. Across the globe, Royal Cyber provides reliable and high performing solutions and services in the space of commerce, cloud, analytics, mobile AI, and middleware. As a ServiceNow Premier partner, we can transform key areas of enterprise service, providing your teams the capacity and insight they need to achieve improvements. Our ServiceNow practice helps our client transform their enterprise service management capability to improve value, increase agility, and create viable business performances. You will discover how Royal Cyber delivers the ServiceNow better, faster, and cheaper service and help your entire enterprise function at its best. Now let's talk about predictive intelligence. And before we begin, let's understand what are the business challenges which create the need of predictive intelligence in an organization. As we are in the era of digital transformation, every organization or business wanted to move and migrate towards digital transformation. Machine learning has all the potential to facilitate and accelerate overall digital transformation for the organization. However, business leaders still face difficulty when it comes to implementing these capabilities. In service focused department like IT, HR, customer service, agents spend a lot or large percentage of their time performing repetitive works, low value work like categorizing or prioritizing requests, searching for similar incidents and cases, and finding the right team to handle the work. These manual steps introduce human error, slow down the resolution time, and ultimately lower customer satisfaction. These challenges create the need for predictive intelligence in an organization. Now let's talk about what is predictive intelligence and what it will provide. Predictive intelligence is the implementation of artificial intelligence or machine learning in Now platform that makes predictions and recommendations based on user inputs. Using machine learning algorithms, predictive intelligence can learn from contextual data, understand patterns, and more accurately predict outcomes without manual intervention. Predictive intelligence also helps teams to work faster by recommending content to agents after making connections between incidents, cases, alerts, and knowledge articles. Predictive intelligence also accurately categorize, assign, and prioritize incoming requests, freeing team to focus on the problem solving that human can do best. Thus, we can say that predictive intelligence is a set of machine learning capabilities that integrates with ServiceNow workflows to enhance business efficiency and improve service. Now let's talk about what predictive intelligence can do. Predictive intelligence provides an interface by which customer can train machine learning models using the ServiceNow AI platform. The machine learning models will enable customers to predict the behavior, predict or estimate a certain values, segment a population of data into clusters for automated assignment to the appropriate teams, identify the data records that are similar in nature for analysis purpose, automated knowledge generation, instance knowledge sharing across the team. These are some um, activities that predictive intelligence can do. Now let's talk about the benefits provided by predictive intelligence. Predictive intelligence provide organizations and agents with the powerful and unique benefits that improve their work experiences. Let's discuss some of the important benefits that predictive intelligence bring to an organization. Predictive intelligence helps to optimize resource and reduce cost by reducing the number of required interactions, by correctly assigning tasks to the right agents with the right prioritization, so they can address issues at the speed of business. Predictive intelligence helps to increase fulfiller or requester productivity by reducing assignment error rates, which enables resolution and fulfillment teams to focus on more complex tasks and requests. Predictive intelligence also helps to improve overall business efficiency by providing consistent and reliable information that allows the business to exceed service level agreement and increase customer satisfaction with accurate categorization, prioritization, and routing. It helps to improve customer service and the satisfaction by decreasing resolution time and errors to recommended action in the context of business, lead to greater customer and employee satisfaction. Now let's move to the next slide. So far, we discussed about what is predictive intelligence, what it can provide, and benefits of predictive intelligence. Now let's do a deep dive and understand how it works, what is that architecture behind that application. Firstly, let's understand how predictive intelligence works. Let's take an example of auto assigning assignment group based on short description. In this case, support user created a new incident with some short description related to SAP email issue. Post submission of this incident, business rule is triggered, which calls the predictive intelligence API. This API use a short description with trained model and provide prediction of email assignment group, which is having an accuracy of 95% and threshold of 85%. As the accuracy is greater than the threshold, assignment group email is set to that incident based on predictions. Thus, for predictive intelligence to accurately predict, categorize, prioritize, auto assign, finding the similar records or grouping the similar records, customer need to train their ServiceNow instances. Training the instance allow predictive intelligence to learn from patterns in customer historical data and continuously improve its accuracy in prediction and similarity matches. Now let's see how that model training is performed and what is the architecture behind it. To train customer ServiceNow instance, all artifacts, which include solution definition and historical records, are packaged into an update set and exported to the nearest training server at a ServiceNow data center. Training can take up to a few hours. When training is complete, the training server remove all customer data and send the model back to the customer instance. Below are the components that is being involved in this training process. Customer instance, which contains historical data and the solution definitions required to train the solution. Customer send the request for trainer server to build a model. Request for training creates a token which is valid for 6 hours. The scheduler, which is there in global instance, waits until there is an available trainer server. The trainer server, which is available at ServiceNow data center, run asynchronously and check the scheduler every 2 minutes to see if there is a job available. If there is a job, it pulls the data to start training. The training server processes and prepare the input data to generate the solutions by removing any problematic characters, identifying and indexing duplicate records, tokenizing and breaking text into engrams, and removing the stop words, and stemming a process which identify the root words for the given text input. Once training is done, the trainer will push the following artifacts to the customer instance, like solution statistics or similarity examples, or the models. Once the model is trained, and when a prediction request happens for the first time, the model is pushed to the prediction server from the customer instance and coached on the prediction server for subsequent usage of the model. So now let's move to the next slide. Now we understood the architecture behind the predictive intelligence application. Now let's understand the capabilities it offers. The AI and machine learning capabilities fall into two categories: supervised learning and unsupervised learning. Supervised learning attempts to explain the behavior of or predict a value for a target attribute. Unsupervised learning has the goal of discovering unknown relationships and patterns in data. Classification and regressions are the example of supervised learning, while similarity and clustering are examples of unsupervised learning. Let's move to the next slide. In this slide, we will examine how a supervised model uses the data. With supervised learning, the model is used to predict either a characteristic or a number for a target attribute. To generate predictions, your dataset contains many rows of input and expected output data. This will create a model that will predict an output value for a new row given input attributes. As example, as shown in the example, first 80% of the data model to generate predictive target values, which is shown in the purple color. Second, you apply the model to the 20% of the input data. Third, the predicted output values are compared to the known output to generate accuracy statistics. These are examined in the next tab. To build a model and to generate predictions, training and testing will be performed for a supervised model. Let's move to the next slide. In this slide, we will examine how a supervised model uses the data. Unsupervised learning models are used to find previously unknown patterns or relationships in data. Therefore, no previously known result is used to guide the algorithm in building the models. This being the case, unsupervised model do not train and test in order to generate prediction for a target. Rather, these models are built and applied to discover patterns and relationship in the data. Since unsupervised models do not identify target attributes for prediction, all table or view attributes are considered as input for these model types. Let's understand from clustering and similarity model perspective. Clustering model identifies segment of the data, predicting which records belong together without explaining why. In this below example, these three clusters are generated from the input data. In case of similarity model, a single record is compared to many other records. The model returns those records that meet the similarity threshold for the input record. The similar records are returned in the ranked order. In this example, three similar records are returned in the ranked order. Now let's talk about different frameworks available in predictive intelligence. Predictive intelligence provides design, execution, and output of prediction models that target project stakeholders with the information they need. Predictive intelligence uses four different model frameworks: classification, similarity, clustering, and regression. Each framework specializes in different type of predictions. Classification provides tactical relief for agents by auto-populating fields that are critical. Similarity framework helps agents to resolve incidents faster by linking them to similar incidents or relevant knowledge articles. Clustering frameworks help agents to plug knowledge gaps more efficiently and alert service owners to major incidents as they develop. Regression framework helps service owners can estimate the amount of time it takes an agent to resolve an incident or a case. Now let's talk each of these framework in detail. The predictive intelligence classification framework identifies and explains behaviors, enabling customers to use machine learning algorithms to set the field values during record creation. For example, you can use a model to set the incident category based on short description. You can train predictive models so that they act as an agent to categorize and route work automatically based on your past record handling experience. Classification framework provide following outcomes like faster resolution time for improved customer experiences, quick time to value with pre-built solutions, reduce error rates and cost, and increasing agents' ability to focus on more meaningful tasks. We have already seen that example when we demonstrated how predictive intelligence works. Let's move to the next slide. So please find respective forms which is used while configuring and viewing the classification model. We will discuss these forms in detail during our demo sessions. So this is a form which is used to select the respective model, and this is the form where you define the solution definition. Here you will see all the respective solutions generated. Here you will talk about the solution statistics, and here you will see the class confidence. The predictive intelligence similarity framework identifies existing record that have similar values to a new record. It generates recommendation based on text inputs that assist staff for routing incidents or cases to an appropriate team. Customer use the framework to build a word corpus. Now the word corpus function as a vocabulary that the system uses to compare trained records based on their textual similarity. For example, customer can train a subset of incidents records to a recommended a resolution based on the information of a similar incident record. By reusing similar close incidents that have a proven resolution, customer can help agents and fulfillers quickly provide the best resolution for an incoming incident. The similarity framework doesn't need an exact match of words for its text comparison because its algorithm identifies similar words and synonyms based on the similar context. Now please find the respective forms which is being used while configuring and viewing the similarity model. We will discuss these forms in detail during our demo sessions. So this is the same way how we use in a classification framework. Here you will create a new solution. This is a solution definition of similarity model. Here you will see the solution which is created for similarity model. Here you will see the example that the prediction server provide. And here you will define see the threshold setup for similarity. The predictive intelligence clustering framework identifies data segments and may be used to improve detection time for high priority incidents. Clustering divides data into groups that can be used to identify patterns. Customer can then address records collectively or find gaps in an existing data. For example, customer can group similar new incidents to identify a major outage. Clustering frameworks help customer to identify patterns, uncover automation opportunities, and to prioritize the knowledge base article creation. Now, please find the respective forms which is being used while configuring and viewing the clustering model. We will discuss this form in detail during our demo session. Here you will see how to create a clustering solution. Here you will see the solution definition. Here we define the solutions belonging to clustering. Here you will see the summary of the cluster models and the visualization belong to clusters. Now the last model is regression. Regression is a machine learning framework that you can train with historic data to predict numeric outputs such as temperature or a stock price. Regression framework can used directly to measure success. For example, you can use regression to estimate the time it takes to resolve an incident or a case. Regression framework help customers to predict time needed to solve a case or an incident, improve planning by forecasting estimates, or predict probability of change success. Now here we will find the screens which will be used for regression model. We will discuss the same during our demo session. So this is a screen which is used for creating a regression. Here you will find a solution definition screen. Here you will find the statistics that is being provided by the prediction server. Now we understood the predictive intelligence architecture, capabilities, and frameworks. Now let us understand the process for implementing the predictive intelligence in an organization. Generally, predictive intelligence implementation takes 14 days for initial setup and varies from customer to customer depending upon the data set used. At the start of implementation journey, customer begin with cloning production data to sub-production environment and then enable the PI plugin in sub-production environment. Post plugin enablement, customer need to configure solution definition and submit them for training. Once training is complete, test solutions to make sure their performance is adequate. If the solution do not meet customer needs, then tweak the solution definition and retrain them. Repeat these steps until we get the desired results. This entire process roughly takes 2 to 10 days. On day 11 and 12, test the final solution through the testing process. Once the solution is tested, same can be implemented in production. Now let's talk about the use case of predictive intelligence with respect to incident management process. We can use all four models to get desired results for incident management. Like classification model is used to identify behavior, which will help to categorize incident type for routing to the appropriate group. Likewise, similarity model is used to generate recommendations based on text input, which will help to identify similar incidents for IT staff. Clustering model is used to identify data segment, which will help to improve detection times for major incidents. And regression model is used to measure success, which will help to improve mean time to resolve or repair. Now let's move to the demonstration part of predictive intelligence. Here we will use the Royal Cyber ServiceNow environment, which has respective plugin enablement in the system. As part of the demonstration, we will first see the usage of predictive intelligence in an operational environment, and then we will review the respective configurations. We will review classification framework from supervised learning and similarity framework from unsupervised learning for this demonstration. So let me log in into that environment. In this environment, we have already enabled the respective plugins for predictive intelligence. The first step, let me show you how the predictive intelligence actually work for an organization when you have enabled the solution, when you have trained the solution, and how you will use it out. So let me first log into that employee portal. Here we are using the predictive intelligence with virtual agent. So here you can see there is a chat option available for the end users. Let me enable the chat options here. So here we have defined a topic for utilizing the predictive intelligence. Let me click on it and let me say self-service support. So here let me mention it out the issue that we are facing. So we are facing an issue with respect to Outlook. And let me just send it out. Based on that information which this virtual agent receives, it identifies the knowledge article, and that is what it will provide it out here based on the predictive intelligence respective models. So here you can see it is providing us this article to resolve this issue. And if I would say no, this, if I open it out, this is an article that tries to solve the Outlook issue problem. Let's assume that this article is not relevant for our need. Let me click it on no. Then again, this virtual agent tries to review the similar incidents and show you the best possible one similar to this particular problem statement. And here you will find the incident number. This result again generated based on the predictive intelligence similarity model. And here you will see the incident over there. So this is one of the use case where we leverage the predictive intelligence models to generate the desired result. And in this scenario, we have used similarity model to generate these outcomes. Let me show you the usage of predictive intelligence with respect to support agent. So let me create a new incident, and let me just provide a short description as Outlook issues, and provide the description the same, and assigning to a group Office 365 support, and just save it out. What we have done, we have created a couple of UI actions to support the predictive intelligence in an incident form. So for to elevate or to enhance the functionality or to enhance the productivity of a support agent, we created two UI actions with reflect to predicting the similar incident and predicting the helpful knowledge articles. So here let's click it on the predict helpful knowledge article. So what it will do, it will review based on the short description and it will predict the respective knowledge article. When you click on it, here you will find that it predicted the knowledge article that could be relevant to resolve this issue. The agent will simply click on this knowledge article and review that information, and if it would be helpful, then he can simply go and close that record. So this is the usage of enabling the predictive intelligence at an organization level. Now let us see how these configurations need to be performed in the system, where we need to go and how to configure these things. So to do these things, the first step is to define the solution definition. So let's go to that similarity. So first of all, you need to go to predictive intelligence application. And in predictive intelligence application, let's go to the classification as a definition, because this is the first model that we are going to review. And in the under classification, you will see the solution definitions. Let me click on the solution definition. And for the demonstration purpose, let me pick the assignment group prediction solution definition for our understanding. So this is a definition that I have created in my environment. Let us understand that what all things that you need to define and configure a definition. So here we have defined a name for the specific definition. Here we are trying to predict the assignment group. So that is the name that we have given for this definition. Automatically, a name is being generated by the ServiceNow system. Then we need to provide the word corpus. Now as I've already explained previously, that what do you mean by word corpus here? A word corpus is nothing but a vocabulary which provide context to various words used within the input records. If we left empty for a classification model, let's assume if we do not provide any details over here, the system will attempt to create one if it identifies at least one text column in the input data. Then we need to provide the table and the output fields. Here the table contains the input attribute and the output and the target attributes. Output field identifies the target attribute field from the table. So in our case, we are selecting incident as a table and we are selecting output field as an assignment group because we want assignment group as an output information. Now the fields refer to one of the input data fields to be used by the model for predicting target attribute values. In this example, we use short description field for input the data model. This is the field which is being used now to identify the classification of an assignment group. Filters are the optional element that enables the refined selection criteria for the input data by specifying condition on the data set. It is nothing but bringing the good data set for doing the predictions. In this model, the condition only returns record with the assignment group empty, with the assignment group not empty, short description is not empty, and the state is closed. Because if we have this data set, it will give you the correct predictions. So that is the important factor that you need to know, that what filters you need to define for your data to be predicted. Then we need to provide the processing language as English and stop words to be used for this model. In our case, we use default English stop words. If I'll just show you quickly on that point, these are the default stop words. So we do not want these words to be reviewed and predicted accordingly. So that's the reason we excluded these words. And at last, the thing is known as training frequency. Here we offer a different type of training frequency. Like you want to run it once, you want to run it with every 7 days, 30 days, 60 days. So these are the different frequency which is being offered by ServiceNow. Once we provided all the parameters for solution definition, simply click on submit and save the definition. Here in our case, it is already submitted. So you get an option of updating that particular definition, and you do find an option of update and retrain. So it means if you wanted to retrain this model, you simply click on it and it will do the retraining for you. And once the solution is trained, you will find here all the solutions which is previously being generated based on these definitions. We need to find the active solution which is there for this solution definition. So this is one of the active solution that we do have. If I simply click on this definition solution here, we will find these solution statistics which talks about the solution precision and the coverage. And then if we talk about, this is a definition which is being used, and if you need to do the solution, if you wanted to try here, you can do the testing as well. So here you are getting it out that whenever you are providing this as a short description, it will provide the class or it will provide the group as Office 365 having a confidence level of 66%. Wherever they have set the threshold as 48, it means it will automatically set this group to that incident record. So that is what you will find it out here. You can validate the testing part around it. So now let me show the other definition. So let's talk about the similarity framework. And let me go to the solution definition. So the same way, let's review the solution definition of the similarity framework. This time we will use the MLKB for incidents. Let me open this one. Okay. So we proceed with the same way of providing label, name, and word corpus, like how we did it for the classification framework. Here we need to provide these details. The only difference that you can see it out here, that here you need to provide the table, fields, and the test table and the test fields, because this is nothing but a similarity. So here we need to provide specifically what is the test table and the test field. As we know, the outcome that we want to achieve with this similarity definition is to know the knowledge articles or the relevant knowledge article for incidents. So here when we talk about the table field is used, which we want from similarity results. So we want the knowledge to be provided, and how this knowledge to be provided, it needs to be reviewed against that incident table. And how it needs to be compared, it needs to be compared based on the short description fields. So that is the reason we have provided the field from a knowledge table, that the short description needs to be compared with the short description field of the incident table, and based on that it provides the result. Now the same way the filter is used here to define the data set to identify the records. Processing language and the stop words are the same, how we use it in case of classification framework. The same way we do have a training frequency and update frequency. The similarity score threshold is the threshold. If it crosses that threshold, then it will set that particular value. So that is where we have seen the previous example. If it goes beyond that threshold, then only it will set that information. So this is an example of how a similarity definition is being designed. Now if you see, this is a ML solutions which is getting generated based on the similarity definition. So let me open one of these solution definition. So here you see an example of the solutions that is being created once you train the respective model. It says that the similarity score threshold set to 80. And if you really need to set the short solution, you just need to provide the solution here. And if you simply run the test, here you validate that this is a knowledge article that is being displayed. So this way, first you train the solution, first you define the solution definition. Once it is defined, you train that solution. Once you trained it out, you validate the solution, like testing the solution, where you can provide a set of data to validate. And when I'm saying top N1, it means whatever the toppest result, just provide that information. What is that confidence that we are getting? Because we are getting the confidence of 99.99%. And that's the reason it is greater than the threshold value. So automatically it will predict this knowledge article when we run that predictive intelligence model. So this is how these definitions are getting stored or defined in the system, how you can review the solution, and how you can test the solution. Let me move back. So now we have finished our demonstration. So we have an exclusive event offer for our participants who have joined this webinar. We offer like complimentary assessment, where we review the process and provide assessment report covering proposed solution, implementation plan, and timelines. Also, we have a predictive intelligence jumpstart package for our customers, where we implement a use case of classification framework with a smaller data set within the estimated duration of 3 to 4 weeks. For any further queries, feel free to reach out to us at info@royalcyber.com. Now the last part is about the question and answers. We are nearing to the end of our session. So let me open this forum for the question and answers, and let me see what questions that we have received so far. So the first question that we receive from the audience is predictive intelligence available on tables other than incident, HR, CSM, or knowledge? Then my answer is yes. Predictive intelligence can be expanded to other tables outside of these respective tables. Okay, the next question is, how many records are needed to train a viable solution? Yes, it's a very valid question, a very good question. That you cannot do a training on just 10 records or 100 records. The recommended number of records for training a good solution is from 30,000 through 30 or 3 lakhs. So if you submit more than 3 lakh records, the most recent 3 lakh records are used to train the solution. The next question which I received here is, does predictive intelligence support multiple languages? Then yes, predictive intelligence support multiple languages. Next question is, can classes be excluded from prediction? Mm, yes. Under the class confidence record, select the precision coverage lookup. Combination records where precision is 100 and coverage is 0. So that way you can do that exclusion of classes. What are some common mistakes when creating a solution definition? Again, a nice question here. The incorrect table is selected. This could be one of the common mistake. Data are hard coded in the filter or filter is erroneous. So that is some another type of a problem. There are not enough rows to train the solution, or the wrong input fields have been selected. So these are some common set of errors that we have seen, or the mistake that people do while creating the solution definitions. So I think there is no further questions that I have seen, or if you need a further assistance from our side, feel free to reach out to us at info@royalcyber.com. So thank you everyone and have a good day.